Okay, so I'm going to go over the second way in which we can sketch transformations of functions. If you notice in the tail end of the last video, I already started going into this. I've decided to break it up into two pieces, just so we can have this is how we do the step-by-step method, this is how we do the mapping method. Okay, but either way, they're using the mapping rule. Okay, and that's what this technique is here, mapping rule. Okay, and just like anything else, just like when we were doing the step-by-step method, we have to determine A, K, D, and C, and in order to determine A, K, D, and C correctly, to get the correct D value, you need to factor the A value out. So if you notice here, there's no brackets inside the function here, we just got a number beside the x. So what we do is we factor negative 0.5 out of x, so that we get an x term inside this bracket here, and then negative 2 divided by negative 0.5 becomes a positive 2 divided by 0. Positive 4 when you take a negative 2 divided by a negative 0.5. Okay? And so now we know all the correct values. Now we know our A value. Okay, it's going to be a reflection and its vertical stretch. We know our K value. It's going to be a reflection and it's 0.5, so you think that that's going to be compression horizontally, but it's not going to be. It's going to be a stretch horizontally. Remember, it's the opposite as you expect, or 1 over K. 1 over 0.5 is 2. And then, so there's my K value. My D value here again, D is going to be negative 4. Don't forget to switch that sign when you take it out. And then your K value is exactly as you see it, negative 1. Okay? And of course, they're restated down here as well in the note, just so you have a nice, beautiful version of it. Okay? Then what you want to do, because it's a mapping situation, we have to take the point of the original parent function and we have to transform that point of the original parent function. So what I do is, of course, I realize that it's, if you look here, it's a root function, right? There's an absolute value function. There's the absolute value. So I go ahead and I say to myself, okay, an absolute value function, all right? So I draw my basic absolute value function, and there it is. Okay, nothing crazy. I don't know where those doodles came from. Okay, and then what I do is I go on from there and I say to myself, okay, what do I do? Well, the mapping rule is as follows. If I take my function y equals f at x, and any and every point in it, if I take my transformation factors, k, a, d, and c, and I use them to modify either the x coordinate or the y coordinate, then I'll get a final point, all the way to the final end, like jump all the way right to the end. Okay, you have to be good with your arithmetic. So this is the original function, y equals f at x. This is the resulting transform function. Okay, the one that looks like this. Okay, the crazy, all the transformations. And it'll do that for you. So what I do is I take my k value, and I substitute in my k value, negative 0.5. I take my d value, and I substitute my d value in negative 4. I take my a value, and I substitute it in here, negative 2, beside the, there's a comma between these two, right? It's a comma. So in essence, it does the x part and the y part to it, two separate pieces. Okay, there's my a value of negative 2, and then my c value, I add it on to the end of negative 1. So this is my mapping rule. So this is y is equal to root x mapped to y is equal to negative 2 absolute x. Y is equal to absolute value of x. Y is equal to negative 2 absolute value of negative 0.5 x plus 4. Minus 4. Yeah. Plus 4. That's inside the brackets, and then minus 1. That's what this mapping rule does. It takes the points in y equals root x and turns them into this craziness. Okay, into this transform function. So what I do is I've created a formula for the x part and the y part. So what I do is I do that. Now you can do that just by subbing it in and figuring that out on scrap pieces of paper or whatever you want. But what I do is I do it kind of a little bit step-by-step-ish as well, which some people find is kind of like a hybrid between the two. So what I do is I take my x values and I go x divided by negative 0.5. So 2 divided by negative 0.5 is negative 4. This is my k value, right? That's my k value right there. That's part of my formula. What you would do is you would do by bed mass, you would take your x value of 2 and you would plug it in here. So 2 divided by negative 0.5 is negative 4. And then you would do, by BEDMAS, you would do this minus 4. So that's what I do. First thing I do is I divide by negative 0.5. So 2 divided by negative 0.5. And I'm modifying my x values. So these are my x values. Okay? So I take the 2 divided by negative 0.5 and I get negative 4. I take the 1 divided by negative 0.5, I get negative 2. 0 divided by anything is 0. Okay, negative 1, and I get these calculations, okay, when I divide everything by negative 0.5. Then I go ahead, and this is the same as this, okay, and then all I do is, what's new here is I subtract 4. So I take the negative 4 and I subtract 4. I take the negative 2, subtract 4. Take the 0, subtract 4. Take the 2, subtract 4. Take the 4, subtract 4. And what I get are these, this is my x part of my final function. Then what I do on the opposite side, which is the y side, I suppose, is I do all the y stuff. So first I do my a value. I take my y value and I multiply it by negative 2, by negative 2, by negative 2, multiply by negative 2, multiply it by negative 2. And then I do my other part of my BEDMAS, my addition subtraction. I subtract 1 from everything. So I take my value, I subtract 1, subtract 1, subtract 1, subtract 1, subtract 1. There's nothing, and then of course you get this result, and this result goes here. Now there's nothing to say that you can't sub it all in. Okay, there's nothing to say that you can't go, okay, I'm going to take the point 1, 1, which is really easy, 1, 1, and I'm going to plug it into the formula, negative 0.5, is it minus 4, comma, big comma, because I want to really make sure that I'm not doing these operations in 2 different places together, okay? And then it's ay negative 2, I guess I'll do a bracket, and then minus 1. Okay, and so I'm going to plug this 1 for x into here, and I'm going to plug this 1 for y into here. And then I go ahead and I do the arithmetic. So the 0.11 turns into, I shouldn't say equals, it shouldn't be an equal sign in there. It turns into, well, 1 divided by negative 0.5 is negative 2, minus 4 is negative 6. Okay, 2 times negative 1 is negative 2, minus 1 is negative 3. And then I'm going to get the point 6, negative 3. Okay, so the 1, 1 turns into 6, negative 3. And that's this guy right there. Okay, so you can do each point individually, or you can do the whole table of values sort of step by step if you want to. It doesn't make a difference how you do it. Mapping means you use the formula. Okay, then all you do is you probably have your original on there. I got my original, the green guy, that's the original function. And then I plot all the rest of them. And what I do is I take these points, and I plot them, boop, 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 plot all 5, and then I connect the dots, moving from left to right. If you've made arithmetic errors, it's not going to look like an absolute value function. But if you haven't made arithmetic errors, it should work out nice and pretty. Okay? Remember what's happened to it, right? It's been flipped upside down because of the negative a value, and it's been flipped side and side because of the negative k value. It's been vertically stretched, okay, by a factor of 2, and it's been compressed by a factor, it's been stretched horizontally by a factor of 2. So this is going to make it skinnier, right? The a value is going to make it skinnier, and then the k value is going to stretch it horizontally, which means it stretches it out that way. So it may roughly look kind of the same as what it was before. Okay, and actually it does look exactly the same. Okay? And then what happens is, of course, you move it. Okay, so we go upside down, we go flipped, we go, okay, I make it skinnier, then I make it fatter again, and it's about the same size, and then I move it 4 this way, and then I move it down 1, and there I am here. 4 this way, down. You can see this, 4 spaces this way, down 1. You're still going to see this point that doesn't change. That's the one point that you can be sure that you've got your d value of negative 4, and you've got your k value of negative 1. And then you look at the spacing and try to remember, if I double my y values, and then I stretch out my x values, what actually ends up happening is that it normally would be here, but if I double my y values, it doubles to this, and I double my x values, it doubles to this, and so it actually creates this scenario here. Okay, and this is the correct function. It's shaped correctly. I did my arithmetic correctly, and there you have it. That's mapping. That's how you do it. Okay, so what we're going to do is we're going to do some examples. Okay, so the next note that we take up, we're going to do some examples. Excuse me, and those examples will show us basically how to correctly do these transformations. One of them I'll do using the mapping rule. One of them I'll do using the step-by-step transformation rule. Okay, and that way you don't have to be able to do both. You should be able to explain how they work, but you only have to be good at doing one or the other if you prefer. So you can choose whichever one you want. If you're good with arithmetic and substituting, you're very careful, then mapping is for you. But if you're good with just doing transformations and doubling and halving and moving and all that sort of stuff, then the step-by-step method's for you. So you choose whichever one works better for you and go from there. You really should state the domain and the range for all of this. Okay, when you finish a function, you always probably should be stating the domain and the range. So x such that. Now, we always know that this value here is going to be the d value, which is -4. We always know, okay, well, at least for this one, the domain can be anything, okay? And as a result, there's no restrictions that are there anymore, but it really centers around the d value. Okay, but for this one, at least for the y value, the restriction is created by the k value, or sorry, the c value. Okay, the c value is -1, and because it opens down, it's less than or equal to -1, and then y is a member of real numbers. So boundaries are usually created by your d and your c value. In the case of the domain, because it opens up and keeps on going on forever, that boundary doesn't exist here. But if this was a root function, then a boundary would exist here at d. Okay? So it gives you a little bit of a lowdown. But it's always good to practice doing your domain and range by looking at a graph, okay, and going from there. All right? Or understanding the shape of the transformations. So hopefully that's okay for you. A bit of homework, actually a fair bit of homework for you there. Okay, plus some review work to do. The more of this you practice, the better you'll be. Okay?